Well, good morning to everybody. We start the second event of today, organized by the IFR. At first, I would like to thank Arturo Baroncelli, who is the people who organize all of this event. He's past president of the IFR. He's here, so I think at first to make like this to him. So he asked me to make the chairman of this meeting, and I will accept, and obviously, and I will start. The people that are with us at first. The people. Well, sorry. We already see who was here before. This slide presented by the previous conference are the 5 trends of robotics according to IFR. In this round table, we will work on this to see from the point of view of general industry and also academia what can be the point of interest together. What both part of the world we can help in that for the progress. For that are here people that represent practically particularly part of this area. There is the President of the IFR, Mr. Ito, that we can see here. There is Enrico Anacondia from UCIMU, is technical manager regarding research, regarding technology. After Professor Bicchi, who is president of, I say in Italian, IRIM, because it's an Italian association, that is an association with the goal to follow artificial intelligence, robotics, automation, and that is younger than SIRI, but also very important. And when was founded a few years ago, we always try to cooperate together, and we have a very good relation. Giovanni Legnani, who is vice president of SIRI, being professor, he is also the part of research of SIRI. We can say we represent that. And later, Alexander Verl, who is chairman of research committee of IFR, so absolutely is for IFR what is Legnani for us in SIRI. I think I will leave this and I will sit because it's more comfortable for me. To start the question that are, as I told you, a question regarding this kind of point. So I will start with Professor Verl. Obviously, I cannot ask to everybody of them to speak of all the points. So according what we believe can be their experience, we select some questions that will be given to them. And all these questions are regarding these 5 points. Points that are not changed, obviously, every year, but they are every year, we can say, integrated by IFR, following the trend of the market and the trend of the research also. Professor Alvel, my question is about digital twins. How do you see the impact that academia can offer in extensive development of digital twin technology? And what is its relation with robotics technology, both in terms of research and education?
Well, let me first mention that I think of all these topics that we've seen on the really high on the hype cycle, I think digital twins is the one topic that will disappoint us the least. I think, for example, AI is quite oversold right now. Humanoids are also very, very much hype, but then we will see which pieces of the technology we can use later on. Digital twins really have this advantage that you can make small steps in progress and everybody can do his version. There is no let's say there is no standardization so far, so anybody who does some sort of simulation already sometimes calls his system a digital twin, but that's not the problem. I think that the good thing is everybody tries to do progress. There's many publications. I think there is like 60,000 publications on digital twins just last year. And the gist is that instead of having the real part, the physical entity, you can do your experiments or your forecasts or your optimization based on the virtual entity. And that's a big thing. And everybody has computers available. All the controllers are usually strong enough or have enough compute power, I think, to also run a digital twin and use it to adapt the controls, to improve some compensation and so on and so on. So there's very many applications that we will see and are seeing, and I think the academia really has dug into that, and they're joining forces. There's the simulation guys. There's the guys who do the implementations with the gaming engines and all of this. And then there's the application people also who, make user interfaces to the digital twins and so on. So I'm really looking forward to even more success in that area.
Thank you very much. Professor Legnani, cobots in new application is the concept, the point of the discussion that I asked you to do. Cobot has been one of the major breakthroughs of robot industry from technical and business point of view. How do you think that academia can sustain the piece of both in terms of research and education?
Okay, thank you. Now, cobot is a small number for the moment of the industrial robots which are sold, but the increases in number is very promising for the future. And of course, academia have to deal with this phenomena. In the past, the interest of academia has started many years ago to try to develop industrial machines or robots that interact easily and safely with humans. Now, in the last year, they start becoming some commercial available device, and so the interest is even bigger. I think that academia might give its support both from research and teaching to the student, of course. And there are some, I think that our contribution can be similar to what we do in any new phenomena that is present in industry or in general in the world. So one is to understand exactly the limits and the opportunities of the new technology, because and then we have to teach to the students what is behind them, the technology which is behind them, to exactly know the nature, the possibility, the limit of this kind of products. Because if you do not understand exactly all these things, you might promote a wrong use of one product, in this case, cobots. And one thing that we have to transfer to the young students is that it's not just important the robot, but all which is around the robot itself. Because, one robot is useless, with the exception of maybe very particular cases. The cobot have to operate in a working cell or in a general environment. one good things of the cobot is to be safe and to be easy to be programmed. But the robot itself, if normal cobots are safe, but when you have to operate with something, you have to add some tools. And for example, if you have a safe robot with a knife in your hands, it might become dangerous. So you have not to just look after a safe robot, but a safe working cell, a safe environment. And we have to also to think that sometimes the robot will need to operate with vision system or other system, and we have to form students that will be able to integrate all these kind of things. We have, of course, need to have a contact with the industry to exchange experience, because we need to know the market in which we have to be placed. But we have not just to think to this particular, the application of today, but we have to give the student the curiosity and the basis to develop new things for the futures. And you know, things take time. So we have to work it for today, but also for the future. And we know that we cannot do in a short time things sometimes.
Thank you very much. Education is always very, very important from that point of view. Dr. Enrico Anacondia, l'artificial intelligence and machine learning are having a disruptive impact in different aspects of the present society. You are people that through the association you can see a lot of industry, and you can have a particular point of view on this point. What would you request to school, university, and research centers in order to fully exploit the opportunity offered by artificial intelligence at business level?
Thank you, thank you, Domenico, for the question. I think we are living a disruptive moment with these technologies. We are living this disruptive moment with these technologies because they are taking a new point of view, a new experience, the companies, which must be, of course, created in some way and developed in another way. So I think there are a number of points can be mentioned. The first one has been already mentioned by Professor Legnani. We have to create, let me say, people which have not only theoretical experience, but also a practical experience. So they must be able to drive the innovation from laboratories to the real world, to the business moment, as you can see here around. But in my opinion, there are also almost four points to be mentioned. The first one is we have to develop the knowledge together. We have to create something which is useful, as I mentioned. We need to, sorry, is the word. We need to create cooperation between academia and industry, because this thing must be seen as a part of the same supply chain, let me say. So the value must be created in academia, must be taken to the company, and then on machine company, of course, and then taken to the users. We need to reason in a business way. So also inside the company, we need to create a management which is open to innovation. Sometimes you have a technician, but you have no money inside the company, let me say, because there is no vision sometimes. There is no risk, openness to the risk to new technologies. On the other side, we also understand that the people working in this new technology have another way to think. So we should let's say also create startups, maybe, which are able to supply this technology as a service, because of course a big company working in IT probably use new technology like in artificial intelligence. So every day, they develop something new every day. In a small company, this is not so frequent. So as you do for many other things, such as certification or engineering activities, you buy the knowledge from consultants, from other entities which are specialized. So I think we also create entities. Probably at the beginning there will be startup, then maybe there can be something bigger, which are specialized in topics related to industry, but they are able to develop using these new technologies, a sort of supplier, 100% of you. And another important topic, I think that must be developed is health and safety on the workplace, because we are facing a new challenge. We are working with systems which are not linear, which are not deterministic, while mechanics, electronics, electrical risks are related to situations that can be easily, sometimes not so easy, in other situation, but can be forecasted. You can do a risk analysis if you analyze in very well way. All the situation can be presented. You can imagine what happened. You can have something falling. You can have something electrical which can be shortcut and so on. Here you have a development of the system which is not linear. It depends on what it learns, let me say, during its life as a person. I learned to cook, another cannot do. So, but when I was born, nobody knows what happened later. So how can we forecast the risk for the operator? We need to create, let me say, some procedure that can be also standard, but maybe something different that can be used to develop this risk analysis. In machinery regulation, you will not find the word artificial intelligence. You will find self-evolving the mechanisms, which is everything and nothing. But they are considered, so we have to do something also to take this situation into account, because we need the harmonized standard to go on with the CE marking as we have done so far. Instead, who knows what happened, because we are still discussing about this, how to apply the machinery regulation in the next years. But if you go reading the Annex 1, it's written, if you have no harmonized standard, you need to use a third-party organization for the certification, but also the third-party organization, if they have no idea how to work, they cannot certificate anything. So it's a sort of loop we must get out, because it's a problem. And I think a cooperation among companies and academia can be also a driver to get out from this loop. Thank you.
Great, thank you. Professor Antonio Bicchi, after several years of different experience, the humanoids, everybody can have his opinion before in the last time, but anyway, there are some entrepreneurs that are starting to put in the factory. They start to consider to be used also in industrial robotics, and obviously in service robots, which is the real world. How do you see the contribution of academia in this segment?
Thank you. Thank you for the question. I think this is controversial. In the panel that we just had before, it was interesting to see different points of view. You had a very clear point of view, which, I mean, is sort of, it's not overly positive, let's say. And the argument is basically, well, this is all the investments that we see. Figure AI has 2 billion, 500 capitalization, has investment for 600 millions, 650 millions. But this is a big publicity stunt. After all, the launch of a new product on the electronics market costs 200 millions. So it's just, a big launch of publicity. And another argument that I hear against that is, well, we don't flap our wings to fly. We don't need humanoid robots to do heavy lifting. There are machines that do that better. So I completely with you in that application in industry is not to be dominant there. But on the other side, why are they so dominant now in attention? There are two reasons. One is that, one is kind of obvious. If you want to have robots in environments that are designed for humans, in your house, then you probably need something that looks like or has hands that manage handles that were designed for hands. And that's one reason. But I think there is a deeper one, which has to do with teaching and learning and programming. And one argument that was brought before in this roundtable was the real step change in robotics is to allow easy programming or no programming, low code or no code programming. How do you do that? AI will help, but how will AI help? Large language models are making huge strides, but you need a language and you need examples. So how can we learn? The only source of good data and extensive data that we have are human examples. Only humans know how to do something so far. So we have to learn from humans, from examples given from humans. In the future, I see programming a robot should be not more complex than telling a 3-year-old boy, do this like this. And the robot should do that. Now, you will start this learning of the motor language from examples that will come from humans. So the easiest way is to translate this language in a humanoid. Later on, I think we will learn how to abstract it to other machines and generalize it.
Thank you. It is very important, this point. In fact, what I said before was mainly for industrial robotics because it was an investment. The humanoid is a typical object of service robotics. So this is his word, and in this word has an important role. And this aspect to see him in the human area is very important. So it's a very good point to consider also this aspect of humanoid. Thank you. President Takayuki, sorry, Ito. The mobile manipulators, especially robots, what we call in the past AGV, are now frontier in particular, but not only in logistics. Do you expect or require support from academia, both at research and the educational level?
Yeah, thank you very much for the question. Yeah, I have seen some mobile manipulators in the past several months. For example, last IREX, International Robot Exhibition in Japan, and also some other trade shows. But most of them are still in demonstrated or very prototype stadium yet. But I also see some of already in commercialized. And in any attempt to collect statistics on it, IFR counted a low 4-digit number of the mobile manipulators. And still, overall, there seems to be still quite early stage of development and some issues to be solved. Moving either the base or the manipulator itself in isolation is not an issue, but the challenge certainly lies in a synchronized motion of both. And second, again, safety is a challenge that needs to be addressed. Again, this is not yet solved for the combination but only for the individual components. Third, same as the others topics, programming is also is an area that the high research needs. Further tools to make it easier for the user to program and adapt it a particular application. If we have that, then that will support a greater distribution. And support from academia to address those three challenges would be very important. And expanding the use of use cases is another area where support from universities and research organizations would be essential. And also talking about education to substantially increase the number of the robot, the number of the mobile manipulators out in the field. We both need a more qualified engineer to support such new applications. And also, we also need more people with a very basic training to operate a robot. Yeah, thank you very much.
Thank you very much. Now we make the second round of table. Professor Alexander Ver, in Italy, we consider Germany a country in which there is a fantastic relation between university and the company, more than in Italy, for a question, we can say, historical. How do you see the evolution of the relationship in your country between academia and industry, and what do you recommend for the future?
Thank you. You're kind of right. I think in Germany there is many good interactions between industry and universities, and a little bit more also than maybe in the US or in Italy. But it could be way more. And right now, especially in the robotics, if you look at it, most of the research is done with, let's say, fancy robotics. So it's just AI and robotics and what can we make the robot learn. But it's not so much what helps the industry or how can the industry benefit from that. So I think it's really the industry could approach the universities more and just state problems and say, okay, this is something where you could, if you have a good idea for that, that would help. So I guess the point is this: many students, they have a lot of good creativity, but they apply it to things that are not directly usable in or for the industry. And if the industry would give them more opportunities to work with their tools, with their robots, with their machinery, they would come up with ideas also for this, for these applications. And I think that can be a thing for basically every country. So that's one thing for to distinguish this fancy type of developments and the more down-to-earth applied research. On the other hand, there's, I don't know who invented this saying, there is no two type of research. There's not basic research and applied research. There's only not yet applied research. So even the stuff that is being developed on the fancy side will also eventually maybe used for the real world. So that's my hope. But I think right now, and we see that also in the research committee in IFR, there's maybe 10 times more institutes doing, fancy robotics, and only a few institutes left who do industrial robotics and are looking for industrial applications also.
Thank you very much. And in fact, the problem of research in general is, from the point of view of industry, and to follow real need. And sometimes it's not easy, sometimes are considered perhaps not enough off level for the research with some definition. But anyway, that is something that I think is general, and if there is more connection, sure, there is more possibility to have good results. Now, Giovanni, same question for Italy. So if I want to repeat, but the same question regarding our country. Thank you.
Okay. So I think that in the past, the academic was more devoted to bare research, while industry was more concerned in applied research. But in the last years, I think that the connection and the change has grown. I see, for example, that many students during their standard studies include some stage of internship with industries. But a good things for them to know something about the industry, not just about theory or some ideal concept, but also is good for us professors because we interact with our students, so we interact with the industries, and that become a good way to exchange informations, technology, and also to improve and to keep updated our teaching. One important, even more important things is the PhD student. PhD student spend 3 years on research, and many of the PhD students research on something which is coordinated with industries. In the last years, and now for 1 year, maybe more, we have, for example, the program PNRR in Italy, in which the minister supported with grants this kind of cooperation between university and industries, and that help in this kind of improving the cooperation. In Italy also, we are starting in these years a new kind of teaching programs, which are what we said professional degrees, which is quite different from the standard teaching. And while we in standard teaching, we have most of the classes taught by professor in from podium presentation, ensemble, etc., in which kind of new professional teaching we have the first year of, let's say, theoretical preparation, based preparation of the students, that we have a second year which is in labs, and the third year which is essentially in industries for internships. So with this kind of new teaching organization, we try to prepare a different kind of students which are more able to enter directly and more faster in contact with industries. They will probably be more adapt for some position in industries which are different from people which are typically prepared in a 5-year course. But I think that is also a way to have better interaction with industry, because also in this new style of studying program, we people from industries enter directly, and so the teaching is not just performed by professors, but also from technician arriving from the university. So I think that we have to try to support all this kind of activity, new way of teaching, try to, but to increase the cooperation, we also need to help people to better understanding the different opportunities. Sometimes one limit is that people for industry, especially from little industry, they want something immediately. So they want a student that arrive and in industry and might perform the work better from the first minute. That is not possible. Because one important thing is of course, one important thing is to give some basic preparation to the student that may be applied not always immediately, but also for the future. And the future changes very, very fast. And also to develop new technology sometimes is time is necessary. And I would like to add just a little things related to the first idea from Bicchi, and he said that in some way robot and machine, at least in some application, have to mimic the humans. And I think that this idea is already present in many machines that we have. One thing that I always say to the student, that our machines, probably we didn't have this idea in the mind, but if you compare a modern machine with the humans, you see that the machines have some mechanical structure. We have the skeleton. The machines have the motors. We have the muscle to move the skeleton. And then we also have the electronics, because all the different parts of the human body communicate with electronic impulses, which connect sensors, motor, and the brain. And now artificial intelligence is something to increase this parallelism, to give something more automatics in what is what we do in the brain.
Thank you very much. Now we go to the other side, the industry. Enrico, can you give some idea about how we can recommend to improve the effectiveness of the relation between industry and academia from your side?
Yes, from our side we have different ways to cooperate with academia. As UCIMU, we have a direct, let me say, everyday cooperation with a number of professors and researchers from many universities in Italy and sometimes also abroad. We cooperate with Politecnico di Milano, Politecnico Torino University, Bergamo, Brescia, Perugia, many others. So we exchange opinions, exchange knowledge with them more or less on everyday basis. Then we have let me say, official way to cooperate. We have an agreement with Politecnico Milano to, let me say, introduce topics related to machine tooling in teaching and research done by this university, which has been signed last year among UCIMU and Politecnico Milano, as I mentioned. And then we have a very long experience with the UCIMU prizes. UCIMU prizes this year, tomorrow they will be the delivered to the student winning the prize. As 48 years old, so we will. It's a very old activity. What we do with these prizes, we ask students to prepare thesis, master thesis about 3 topics. They can choose among design of machine tools, robots, and manufacturing systems, technologies related to digitization 4.0, 5.0, and so on, and topics related to sustainability. So this is let me say, the most academic part. So they choose a topic, they develop a thesis, they give to us, we evaluate, and then we choose one for each topic, and we give it a prize. The ceremony will be here tomorrow, if you're interested, tomorrow afternoon. Then we have 3 more prizes. From the next year, there will be 4 more. We ask to our company to host a student or a couple of students to develop a thesis which is related to the company interest, not just say, theoretical and academic, on a theoretical academic point of view. So they created a thesis, of course. Of course, the thesis here is related to our topics on machine tools and other aspects that we are interested in. And then the company, let me say, and the student, of course, with the professor, must demonstrate that there has been an enhancement in the company, in their management, their operation, or their products. So we give, as I mentioned, since this year, 3 more prizes. From the next year, we will give 1 more. And this is done to involve, as I mentioned in the earlier, the cooperation between academia and research, not just theory, but also practical cooperation.
Thank you very much. Sorry, we are very close at the end, so I have to stop sometime. But anyway, regarding the opinion of Antonio regarding the national and the European programs of research is another very important part of this world. It is very important. So thank you if you can answer on this point.
Yes. So what if I could make a program, a funding program, what would I do? That's I think I'll start with a story. I don't know if everybody knows or agrees on the story of cobotics, collaborative robotics. So that was, I think, the first one I would credit to Bill Townsend with one, reducing the inertia and taking consideration of safety. But that was very early, too early. So in the real world, if you are too early with an idea, it doesn't really mean that you have success. Then it was the cobotics from Pershkin and Colgate, the company, but that is another kind of sector. The real industrial cobotics that we have today, I think should be considered to be born out of a couple of European projects early in the 2000s. One was in Sweden, ABB and Lund and German partners. And one was Germany and Italy. It was France. It was Italian universities and DLR and KUKA. So these two really started the field of cobotics. And for several years, cobotics was mainly European. Then, of course, everything goes and, everything. So that were 2 European projects that started a new branch of research that then for some 10 years allowed Europe to be leader. Now, I think that is an example of a successful investment. What lessons? I think what we have more recently, now today we couldn't have that. Because today we have 2 problems. One is too short-sighted funding. The horizon is 4 or 5 years. I think the horizon should be 10, 15 years of return on investment. And second is that people designing projects now in Europe are giving us solutions. They should give us, industries and research, they should give us problems, not solutions. So the next generation of projects will be about generative AI. You do whatever you want, but use generative AI. You have a solution, you have this hammer, and you look for problems. It's the other way around. So on this, I'm very harsh. Should be, this is a problem. This is an industrial problem we want to solve. This is a, service robotics, robots for the house, or whatever problem. Find the tools to solve it, not the other way around. So that's my position.
Thank you very much. Very interesting. President Takayuki Ito, what is your opinion regarding this point, the academia and the industry?
Yeah, that's a very difficult question because there is a very broad spectrum of cooperation between industry and academia.
Yes, in fact, I already leave it to you to speak about that because perhaps you also have a different idea regarding cooperation. So please, thank you.
Yeah, anyway. And such cooperation, it ranges from the very early stage of the research project around cooperation to aim to solve a customer-specific problem. But I think it is a very it is of a great importance to have a mutual understanding of the exact requirement and also expected outcome, as well as same criteria of the success rate, success and failure. I think really this is really key for the efficient way of cooperation. Let me give you some example. Success rate of 99%. You may think this is a really good, great outcome for the project, especially for R&D project. But if you look into the detail, this means you get one failure in 100 trials. This means if you have a robot application with 1 minute cycle, then robot may stop on average once in 100 minutes, which is less than 2 hours. So that means if you have any equipment in your office or in your factory that fails once in 2 hours, can you accept it? You may kick it out. So that kind of understanding or criteria of the understanding is very important. But on the other hand, such as R&D collaboration also allowed tackling the challenges that will never be feasible to be solved for industrial company alone. It can bring in fresh ideas and new concepts that open up a new way of thinking. So last but not least, we should also not forget that great innovation gained via successful technology transfer from academia to industry. And also should not miss to mention that many successful startups that have once spun off from a university or research institute. Yeah, thank you very much.
Thank you to you. Well, there is some question from the stage. Well, I think if there are no questions, I think that thanks to your presences, your idea, we have a general idea about the situation between academia and research and companies in our world, the world of robotics, that is really a pillar for the development of any technology, not only robotics. So I will thank you very much, everybody, for your presence, for your contribution to this roundtable, and I propose an applause from the stage to all of you.